Well, student, in the last lecture, we had completed about the property of the charges. There are three properties: additivity of the charges, conservation of the charges, and the third property, it is called the quantization of the charges. Now, today is the next topic. It is about the Coulomb's law. The next topic, it is about the which law? Coulomb's law. Well, Coulomb is a name of scientist who stated this statement. That is why it is called the Coulomb's law. So, in this Coulomb's law, it is similar to the gravitational law. It is similar to the which law? Gravitational law. And that gravitational law we had studied in gravitational chapter in 11th science. It is very much similar to that gravitational law. Okay. Now the statement of the Coulomb's law, it is which one? In Coulomb's law, we require 2 point charges. In Coulomb's law, we require 2 stationary point charges. And that stationary point charges, it is named as Q1 and Q2, and they are separated by distance r. That is to be shown into this diagram. There is a 2 stationary point charges Q1 and Q2. They are separated by distance r. Now the Coulomb's law, the statement can be given like this: the electrical attractive or repulsive force acting between the 2 stationary point charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. This force is acting on the line joining them. This is called the statement of the Coulomb's law. Once again, student, the statement of the Coulomb's law: the electrical attractive or repulsive force acting between the 2 stationary point charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them, and this force is acting on the line joining them. This total statement, it is to be written down on this board. The statement is given by like this: Coulomb's law states that the force of attraction and the repulsion between the 2 stationary point charges is directly proportional to the product of 2 charges and inversely proportional to the square of distance between them. This force acts along the line joining the 2 charges. In this statement of the Coulomb's law, there are 2 main things. Force is directly proportional to the product of their charges. So that mathematically can be expressed as F is proportional to Q1 into Q2. And another statement: this force is acting inversely proportional to the square of distance between them. Mathematically, it can be expressed like this: F is proportional to 1 by r square. So that, student, we can say that F is proportional to Q1 into Q2, F is proportional to 1 by r square. By combining these 2 equations, now the equation of Coulomb's law can be given by F is proportional to Q1 Q2 by r square. To remove this proportionality sign, multiply some constant. That constant, it is called the small k. Therefore, the equation of Coulomb's law can be given by F is equal to small k Q1 Q2 by r square. This is your equation number 1. Where k is equal to, it is called the constant of proportionality, or it is also known as an electrostatic force constant. Why we are using this word electrostatic? Because, student, chapter number 1 and chapter number 2, in which the charged particle are remain stationary, that is why it is known as a electrostatic force constant. Static means what? Stationary. Okay. So now, student, next things. This value of k depends on the nature of medium between the 2 charges. This value of k depends upon the nature of the medium between the 2 charges. If the medium is changed, value of the k is changed. But medium does not change, the value of the k does not change. Okay? So now, student, next things. Equation of K can be given by like this. It is a K is equal to 1 upon 4 pi epsilon 0. K is equal to 1 upon 4 pi epsilon 0. This equation it is applicable when the two charges are located in a free space. This equation is applicable when the two charges are located in a free space. Free space means what? It is a vacuum. When these two charge particles are placed in a vacuum, that time the K is equal to denoted by 1 upon 4 pi epsilon 0. See student, this is a symbol of the epsilon 0. And this value of the K, that is 9 into 10 raised to 9 Newton meter square upon Coulomb square. The value of the K is fixed value in vacuum, that is 9 into 10 raised to 9 Newton meter square upon Coulomb square. Student, how to make this unit of K? So please student, in the equation number 1, make a subject of K, where unit of the force is Newton. See, this is distance R, so that write down meter square. Unit of charge is Q1 is equal to Coulomb, again into Coulomb square. So by making a subject of K, this is Newton into meter square by this Coulomb square. It is a unit of the what K? It is a unit of K. Where epsilon 0 is equal to, it is called the permittivity of free space. Where epsilon 0 is equal to, it is a permittivity of free space. Again student, a free space means what? It is a vacuum. Also you can say that it is a permittivity in vacuum. Also you can say that it is a permittivity in a vacuum. Okay. Now the value of epsilon 0 in vacuum can be given by like this. It is a 8.854 into 10 raised to minus 12 into 10 raised to minus 12. Unit of the epsilon 0, it is Coulomb square upon Newton meter square. The unit of the epsilon 0 is Coulomb square upon Newton meter square. Student, please only remember the unit of K. Unit of the K is which one? Newton meter square by Coulomb square. But observe this equation. Relation between the K and epsilon 0, it is inversely proportional to each other. They are inversely proportional to each other. If they are inversely, naturally the unit also going to what? Inverse. So now the unit of epsilon 0, write down inverse form of the K, that is Coulomb square upon Newton meter square. Okay? Please student, now substitute this value of the K into equation number 1, so that now the force can be expressed, equation of the Coulombian force can be expressed like this, that is F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square. It is your equation number 2. This is equation number 2. So that student, there are two equations are completed, are related to the Coulomb's law. First equation of the Coulomb's law can be expressed like this, that is F is equal to K Q1 Q2 by R square. Another form of the force of Coulomb's law, it is given by F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square. Now student, there is a small example. Suppose the value of Q1 Q2 and R, it is 1 only. Value of Q1 Q2 and R, it is 1 only. That is to be represented into this one. Q1 and Q2, it is equal to 1 coulomb. Distance R is equal to 1 meter. So that calculate the value of force. See, value of the K is equal to 9 into 10 raised to 9. Q1 is 1 coulomb, Q2 also 1 coulomb, and it is a 1 meter square. So that right now, value of the K is 9 into 10 raised to 9, 1 into 1, and divided by this 1 square. The answer is coming 9 into 10 raised to 9. When the value of the charge, it is 1 coulomb only, Q1 and Q2. Distance between the two charges is only 1 meter. That time the force acting between the two charges, it is 9 into 10 raised to 9 Newton. It is 9 into 10 raised to 9 Newton. Okay student? So now about the Coulomb's law, some description it is completed. About the Coulomb's law, some description is completed. Well student, Coulomb's law, in which there are two types of forces are acting. Maybe between the two charges attractive force acting, maybe between the two charges repulsive force is acting, but there is a one mathematical expression through which directly we can say that which force is acting, maybe attractive or maybe repulsive. Student, there is a one small question. Suppose the value of Q1 Q2 it is less than 0. Value of Q1 Q2 is less than 0. Less than 0 means what? Multiplication of these two charges coming always negative. multiplication of these two charges always coming negative. Means what? One of the charge is positive and another charge is what? Negative. We know very well between the positive and negative charges which force acting? Attractive. So that when the Q1, Q2 it is less than 0, between them attractive force is acting. Another one, Q1, Q2 it is greater than 0. Q1, Q2 it is greater than 0. Means what? Answer of the multiplication of Q1, Q2 it is more than 0. The answer is always coming positive. So when the answer of the multiplication coming always positive, because when value of the Q1 is plus, value of the Q2 also plus, plus into plus, answer is plus. Suppose both are negative, minus into minus, again answer is coming positive. Means what? Q1, Q2 when greater than 0, then both charges are the like charges. Between the like charges, which force acting? Repulsive force. So that we can say that when Q1, Q2 it is greater than 0, between them repulsive force is acting. So that we can say that Q1, Q2 it is greater than 0, between them the repulsive force is acting. Okay student? Okay. Now student, actually the next things, it is about the epsilon 0. It is about the epsilon 0. The name of the epsilon 0 it is called about permittivity of free space. Now we are coming across the word permittivity. Now we are coming across the word permittivity. So what is the meaning of permittivity? What is the meaning of permittivity? Permittivity means what? It is a property of medium. Permittivity means what? It is a property of medium which determines the force, the electric force between the two charges situated in that medium. Permittivity means what? It is a property of the medium which determines the electric force acting between the two charges located in that medium. It is so that student, when the medium is changed, the value of the force is changed. Maybe these two charged particles are placed in a vacuum, or maybe these two charged particles are placed in another medium. A medium may be like it is a kerosene medium is like a water medium, a medium is like a air medium. The medium change, the electrical force acting between the two charged particles, it is changed. And that is to be calculated by using the word permittivity. Once again student, permittivity means what? It is a property of the medium through which we can determine the electric force acting between the two charges situated in that medium. Now student, medium change, value of the force is changed. How to calculate by changing this medium how much force is acting between the two charges? That is to be explained into this one. Well student, first of all, when the two charged particles they are placed in vacuum, two charged particles are placed in a vacuum, that equation can be expressed like this: F vacuum is equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square. It is your equation number 3. Now these two charged particles are placed in a medium. So now in medium, F medium is equal to 1 upon 4 pi epsilon Q1 Q2 by R square. It is your equation number 4. So now what changes takes place? In place of epsilon 0, now we write down epsilon. Epsilon is what? It is a permittivity in a given medium. The medium change, permittivity change. Epsilon 0, it is a permittivity in a vacuum or in a free space. Epsilon, it is a permittivity in a given medium. Okay, the medium change, permittivity change. Now equation number 3 divided by equation number 4. So that now equation can be written like this: F vacuum upon F medium is equal to 1 upon 4 pi epsilon 0 Q1 Q2 by R square 1 upon 4 pi epsilon Q1 Q2 by R square. So now you can see that 1 upon 4 pi cancel. Q1 Q2 by R square Q1 Q2 by R square cancel. Now the which term remaining only 1 upon epsilon 0 and 1 by epsilon remain. This division to division is numerator, so that this equation can be write down epsilon by epsilon naught. Epsilon by epsilon naught. It is your equation number 5. It is your equation number 5. Okay. Now the next thing student, how to represent this epsilon upon epsilon naught? Now there is a next new equation. Next there is a new equation. So then epsilon by epsilon naught, it is equal to capital K. Student, it is equal to capital K, not small k. In the proportionality constant, we are using small k, but epsilon by epsilon naught is equal to, we are using capital K. And that capital K is equal to also denoted by epsilon r. And epsilon r, it is known as a relative permittivity. Epsilon r, it is known as a relative permittivity, or it is known as a dielectric constant. Epsilon upon epsilon naught, it is equal to capital K, or you can say it is epsilon r. Epsilon r means what? It is known as the relative permittivity, or known as dielectric constant, or known as a dielectric constant. So dear student, epsilon by epsilon naught now replaced by capital K. Now replaced by capital K. Rewrite equation number 5 so that we can write down F vacuum by F medium is equal to capital K. Now please student make a subject of F medium. So this is to be written down in division. So that F medium is equal to F vacuum by K. Student, now observe this equation. In the medium, the value of the force becomes the kth part. In the medium, the value of the force becomes the kth part of the original force. Or also we can explain like this. The value of the force becomes the 1 by k times of the original force. In the medium, the value of the force becomes the 1 by k times of the original force. Or also you can say that the value of the force in a given medium becomes a which part? Kth part. Becomes a which part? Kth part. So some value of the k, it is to be shown into this board. In vacuum, the value of the k is 1. In vacuum, value of the k is 1. In air medium, value of the k is 1.0000054. In air, value of the k is 1.00054. In water, value of the k is what? 80. In water, value of the k is what? 80. Substitute this value into above equation. K replaced by suppose 80. Then what happens? The value of the k, the value of the force in water medium becomes a which part? 80th part. This becomes a which part? 80th part. Okay student? Permittivity means what? It is determined the what value of the force when the charged particle are placed in a different medium. Permittivity means what? It is a property of the medium. By changing the medium, the value of the force is changed, and that value of the force can be calculated using this equation. That value of the force can be calculated using this equation. Okay student? Now the next thing student. Today we studied about the Coulomb's law. But yeah, there is some limitations of the Coulomb's law. This Coulomb's law, it is not applicable for any distances. It is not applicable for any distances. When the distance between the two charged particles, it is less than that of 10 raised to minus 15 meter. So 10 raised to minus 15 meter distance, it is represent the radius of nucleus. 10 raised to minus 15 meter, it is represent the radius of nucleus. Whenever the distances are less than 10 raised to minus 15 meter, then Coulombian force, it is not applicable. This Coulomb's law, it is not applicable because when the distances are becomes less than 10 raised to minus 15 meter, between them the nuclear forces are acting. Between them the nuclear forces are acting. See, this is the limitations of the Coulomb's law. It is the limitations of the Coulomb's law. So again student, if the distance between 2 point charges is less than 10 raised to minus 15 meter, then Coulomb's law is not applicable because the distance is less than 10 raised to minus 15 meter. Between the two charges, nuclear forces are acting. Between the two charges, the nuclear forces are acting. Okay? So now the last thing is remaining about this topic. There is some dimensional formula. There is some dimensional formula. That dimensional formula, it is to be represented like this. First of all, derive the dimensional formula of the small k, then derive the dimensional formula of the epsilon 0, and derive the dimensional formula of the epsilon 0 in terms of Q charge. In terms of the Q charge. So first of all, there is a dimensional formula of the small k. All the dimensional formula can be derived with the help of the unit. All the dimensional formula can be derived with the help of their unit. What is unit of K, student? The Newton meter square by Coulomb square. Now we know very well, already studied in 11th science, the dimensional formula Newton is equal to, it is a m1 L1 t raised to minus 2. Dimensional formula of the meter square means it is a length square and it is a L square. Dimension of the Coulomb is equal to, it is a A1 T1 and it is a whole square. So student, now it is a M1 A series, L1 L2 means L3, t raised to minus 2 divided by, it is a square and there is a t square. Now the next calculation, M1 it is A series, M1 A series, L3 A series. This is t raised to minus 2 divided by t raised to 2. Write down in numerator so that t raised to minus 4. A raised to 2, write down in numerator, A raised to minus 2. So the dimensional formula of the small k, it is a M1, L3, t raised to minus 4 and A raised to minus 2. Student, already we studied the relation between the k and epsilon 0. The relation between the k and epsilon 0, it is inversely proportional to each other. It is inversely proportional to each other. Students, you can see that the relation between the k and epsilon 0 inversely proportional to each other. So that a directly dimensional formula of the epsilon 0 can be written down from this dimensional formula or from this equation. It is a inversely proportional to each other, so that directly you can write down m raised to minus 1, l raised to minus 3, t raised to plus 4 and a raised to plus 2. And also you can derive with the help of their unit, write down the inverse unit of k, Coulomb square upon Newton meter square. Once again there is same calculation, the Coulomb is equal to A1 T1, Newton is equal to M1 L1 t raised to minus 2, meter square means what, L square. So the dimensional formula of the epsilon 0, m raised to minus 1, l raised to minus 3, t raised to 4 and a raised to 2. Okay. And then now last thing, student, write down the dimensional formula in terms of charge q. Write down the dimensional formula in terms of charge q. Well, student, when we write down the dimensional formula in terms of charge q, only small changes takes place. Coulomb, it is replaced by capital Q only. Coulomb replaced by capital Q only. Student, this is our Coulomb that is replaced by capital Q only. See, this is Coulomb square, write down Q square. Newton is equal to M1 L1 t raised to minus 2 and meter square is equal, it is a L square. So that dimensional formula of the epsilon 0, it is a m raised to minus 1, l raised to minus 3, t raised to 2 and q square. It is in terms of charge q. Dimensional formula of epsilon 0 in terms of charge q, m raised to minus 1, l raised to minus 3, t raised to 2 and q square. Okay, student? Now today the topic about the Coulomb's law, it is completed. Once again, student, the Coulomb's law, it is applicable only for the distances when the distances are more than 10 raised to minus 15 meter. But the distance is less than 10 raised to minus 15 meter, it is not applicable. It is the limitations of the Coulomb's law. What is the statement of the Coulomb's law? The electrical repulsive or attractive force acting between the two stationary point charges is directly proportional to the product of their charges and inversely proportional to the square of distance between them. This is the statement of the Coulomb's law. In this whole chapter, the equation of the Coulomb's law, it is most applicable and it is more applicable throughout this chapter. Okay, student? Well,